self-driving or automation or artificial intelligence are really going to play out, and what's gonna be first, and how things are going to roll out. But you know that it's coming. And one thing that is very obvious for us, I live in Mountain View, and there isn't a day that I drive by and I see the Waymo cars driving around. This idea of a self-driving car has become a reality. Same guy, Kevin Kelly, actually talks about the first industrial revolution being an artificial power. That's how he describes it, where we first created cars, and with a press of a button or something, now we have the equivalent of 250 horses, the power of them, at our fingertips, and we use those. And this trend that is alive now with artificial intelligence, he's calling that the second industrial revolution, because now we're going to be marrying the artificial power with the artificial intelligence, and that's what gives us things like artificial or self-driving cars. These things are becoming more mainstream. I think in 2017 there were 1 million miles of the self-driving cars being driven on real roads, and people are predicting that by 2030 the majority of the cars on the road are going to be self-driving. So it's a pattern that is on its way, and there's no stopping it at this point. And there are a few reasons for it as to why it's catching on so much. It adds a lot of value. There are sort of four main values that it adds to us, and those are sort of convenience, the comfort, the safety, the added safety, and also the efficiency. Robots and machines are really good at being efficient, unlike humans, and they can concentrate on a single task without them having to worry about when am I going to pick up the kids, and who's gonna do what. So with that in mind, it's a notion that is about to happen, and sort of the thesis of the talk here is that I'm here to convince you that buildings are also on their way for this revolution. They tend to be different than cars. We spend about 90% of our times inside buildings. Yet, you think about your car, especially with the newer ones, you sit in a car, they know exactly what your preferences are, they know what you need, they know how to make you comfortable. Unfortunately, most of the buildings that we currently enter, they feel disconnected, they feel crummy, they feel a little uncomfortable at times even. And there's a lot of motion in bringing buildings up to speed as well, and that's what we'll talk about. So, as a shout out to Ehsan, in the context of the convenience, Ehsan worked on Gate Labs. It's a technology that allows for essentially automated locks, the ability to be able to give access to service providers to enter the home, and it's an obvious convenience that can be added with intelligence added to buildings. The second category is comfort. So how many of you guys have been in a thermostat war in the office or at home? Yeah, most of us have experienced this. Some people want to be cooler, others want to be warmer. I think in the context of a typical family, that seems to be a very obvious and frequent war that goes on. And Comfy, as a company that is, as a side note, they just got acquired by Siemens, but they are working on solving this problem, and they're bringing in user input into making the building more comfortable through automation. So the idea is that people use an app, use their phone, describe that they want their space around them to be warmer or to be cooler. That information gets fed into the HVAC system of the building, and the building management system will up the AC for the areas that want to be cooler, and it'll change essentially the thermostat settings for the areas that need to be warmer. So that automation and intelligence is making people more comfortable. Safety is another sort of notion, and Birdie is a company that's focused on bringing safety in the context of air quality inside buildings. So they do carbon monoxide detection, smoke detection, and overall manage the air quality inside the buildings. And lastly, and this is the area that relates most closely to what I spend my time doing on a day-to-day basis, is efficiency. So building efficiency is a hard problem to solve. There are a lot of different players out there, and people have been doing it in very different ways so far. So there are companies like Enlighted, Carbon Lighthouse, Switch Automation, and of course us as Keewi, that we are focused on bringing intelligence in the context of efficiency in practice. So most people are actually surprised to know that buildings are the category of energy use in the US that is the highest. So among three categories of buildings, transportation, and industrial, buildings are actually the ones that spend about 40% of the total energy use in the US. And what's sad about it is that across the board, on average, about 30% of that energy is lost, is wasted completely. So the idea of energy efficiency for buildings is an important problem to solve. It will have implications not just in the U.S. economy, but also in the context of sort of where what all of our backgrounds are. With countries like Iran, of course, energy matters a whole lot, and this has a global impact. So it's a hard problem to solve, but with great rewards if we're able to make a difference. So this is sort of an introduction about why this idea of energy efficiency and automation and self-driving buildings is worth pursuing. And the way that we at Keewi are doing it is that we automate energy management using the power of big data and occupant engagement. So the other companies that I mentioned, for example, with Carbon Lighthouse and Enlighted, they're looking at the entire building level. And up to this point, they have missed the idea that it's important to bring users into it. When you think about a self-driving car, for example, you know that it's the input from the users that make the AI in that technology work better. It learns over time after it gets input from the users and from people. This concept has not yet been applied to the idea of buildings, and that's exactly what Keewi is doing. We're bridging that gap between automation and the users, and we're enabling people to have a say in how the building energy management is done. So the particular aspect of energy management that we focus on is what we call plug loads. There are sort of three major categories of how energy inside a given building is used. The first one, or probably traditionally the most obvious one, is what we call HVAC, HVAC. That's what deals with heating, cooling, ventilation, and traditionally that has been the biggest sort of part of the bucket of energy use. We also have the overhead lighting. Most people have heard of LED lighting. It's now a mainstream technology that is making buildings more efficient. And the last category is what we focus on, which we call plug loads. And with our sort of change in how we live, with how many electronic devices we all use, that particular category as a percentage of the total building use has been increasing. And there was a study published by the Department of Energy a few years back that actually predicted this category of energy use to be increasing by 50% by 2030. So it's a big problem, it's an increasing problem. There's an explosion of energy waste in buildings through all the electronic equipment that we all use and own. And unfortunately, there isn't a good way to address that problem. So this is what we're doing. And the main challenge with solving this problem is that there's a massive scale of these devices. There are more than 20 billion outlets in the US alone. Imagine if we were to use these as a sensor nodes, but also imagine the scale of the effort that would be required to upgrade all of these and make them intelligent. The other problem is that there's currently no infrastructure for managing the plug loads. And lastly, as I mentioned earlier, people have not been brought into this equation, and they are an important contributor. So I guess a little bit of background about how I got into this and why we started this. My co-founder Jennifer is also a Stanford alum. We came to this due to, based on a mutual interest essentially. So I actually have a background in bioengineering, and after finishing up my graduate work at Stanford, I got the opportunity to go and live in Germany for about 3 years. And that was where I developed an interest in energy efficiency, because Germans are known for doing things efficiently, and I experienced that firsthand. So when I came back to the US, I knew I wanted to be able to do something about this and to really bring that culture of energy conservation to the US, and to make an impact into this problem. And my co-founder Jennifer, she has a background in civil and environmental engineering, so this was definitely up her alley. And so about 3 years ago, we started on this path of wanting to do things differently and making a change in the world here. So we have been very fortunate to be able to work with leading institutions for Keewi up to this point. Our very first 2 customers were San Francisco Airport and Stanford, who we talked to as part of our customer discovery. And we told them, what the idea was and what we're trying to do, and they said, okay, if you build this, we'll buy it. And that was a great success as a non-existing startup yet, to have those entities give us their sort of stamp of approval.
Did you get a LOI from them, or it was just a word of mouth?
We did get an LOI from them, and that in itself essentially put us on the track to launch the rest of the path. So what is the idea? What is the solution? So there are 2 components to what we do. One is bringing that infrastructure of intelligent outlets inside buildings. So moving from the left to the right of the screen, the left side shows a number of different smart outlet options that we have used up to this point, and this is a growing list. And the idea is that these smart outlets essentially do a few relatively simple things that ordinary outlets can't do. So the technology of the outlet is more than 100 years old. It has not changed in this whole time. So for people who patented the idea, if they were to come look at our buildings right now, they would be able to recognize the exact same thing. So what we do is we essentially upgrade this technology so that there's energy data that can be collected at very high frequencies from every socket, and 2, that information can be wirelessly distributed and distributed to a cloud server where the intelligence is actually implemented. So the outlets talk to a central gateway. The gateway is what communicates to the internet, to our cloud server. Excuse me. The server is where essentially